Hi, my name's Barry Olney from In-Circuit Design. This is a demonstration of the new Impedance Goal Seeking feature of the ICD Stackup Planner. For years we have had impedance plots, and impedance plots are good because they allow you to view the 6 variables that you can adjust to get the correct impedance. For a trace, for instance, you have trace width versus impedance, trace thickness, trace clearance, and differential coupling for differential pairs versus impedance. If I select a dielectric, we have dielectric thickness, dielectric constant. Now these 6 variables all need to be adjusted together to give you the correct impedance. And probably an easy way of doing this is by using goal seeking. So what we can do is select a characteristic impedance, for instance, so this microstrip layer, and if I want 50 ohms, I just type in 50 ohms and it changes the trace width and clearance to give me the desired impedance. If, for instance, I want USB 90 ohm differential pairs on the outer layers, I just put in 90 and adjust the trace width and clearance again to give me the 90 ohms impedance. However, if I edit this material, this is just the virtual material of 3 mil, and I select, say for instance, EMC, and I want a 888 material, which is a lucky number for Chinese, and a 1 gigahertz frequency. If I now put in a 3 mil dielectric, or 2.9, which is fairly close, you can see that it varies the impedance slightly, and this is because the dielectric constant is not 4.3 for this particular material, and the thickness is slightly smaller than 3 mil. So we need to compensate for that and trim it up a bit. So we'll just put in 50 here, and we've got 90 ohms roughly for the differential impedance for USB, which is what we wanted. If I go down to this center microstrip layer here, we may want to route DDR3 or 4 on the internal layers, and they have 40 ohms characteristic impedance and an 80 ohm differential impedance. And similarly on the next layer, we may want to put in, say, 50 ohm digital and 100 ohm differential. And so the goal seeking runs multiple passes of the field solver to come up with the correct impedance that we're after. Again, if I put in the actual materials I want to use, the EMC EM888, I want a 6 mil here, so I'll go down here and select 5.9, and again for this one here, I'll select this 5.9 again, and for the core, I want a 5 mil, and I'll select a 5 mil from my library. And again, you can see that because I've got these actual materials in, and we have different thicknesses and different dielectric constants, again, my impedances have changed. So I trim it up again. Give me 4080 for DDR, and 5100 for the digital. And there we have it. Thank you very much.